Okay, everybody, welcome to this video. May peace be upon you all. In the name of God, the most gracious, the most merciful. So in this video, we're going to do the question paper. You can refer to it. Please refer to the question paper NSC February March 2014 question 9. Okay, so we're still busy on electricity. So I'm gonna read the question from my question paper that says that two identical cells, each with an EMF of 1,5 volts. I'm gonna stop there. So we have to learn how to analyze a question. So repeat or follow with me on the question paper. Okay, follow with. So they say that two identical cells, each with an EMF of 1,5 volts and an internal resistance, are connected in series with each other. So we have two cells, and they say each cell has 1,5 volts. 1,5 volts. So before I go to the question, what do you do for yourself on your question paper? You do this for yourself. You draw the classical table for yourself. Okay, you draw the classical table. So series and parallel, voltage and current. Voltage add up, voltage the same, current is the same, and current adds up. Okay, and you can just watch the other video that I explain this. And then what you also have to write down is that V total is equal to, and it must be fastener, V external plus V internal. V total is equal to I total times R total. V external is equal to I external times R external. V internal is equal to I internal times R internal. Equal to and plus. Right though. So you always, to approach a physics question like this, always write down what you know. So they say that the EMF of each cell is 1,5 volts. So the total voltage is actually 3 volts. You understand? So we got the total voltage of 3 volts that's given to us. And then they say, and they give us the diagram, and they say 9.1, define in words the term EMF. I'm not going to do that because that definition you can just learn on your own. So 9.2, write down the total EMF of the circuit. We got that, okay? We got the total EMF of the circuit, which is 3 volts. We add up the individual EMFs of each cell. Now, let's say when switch S is closed, the potential difference across the 4 ohm resistor is 2,4 volts. So when switch S is closed, the potential difference across the 4 ohm resistor is 2,8 volts. So they give us the potential difference here of 2,8 volts. Now I'm not gonna go to the questions yet. I'm gonna stop there. Before I go to question 9,3, I'm gonna stop there and see what can I get. Okay, so for this resistor, they give us the voltage and we have resistance. Now, if you look at Ohm's law, V is equal to IR. We have voltage, we have resistance, meaning we can calculate current. I is equal to V over R. R is equal to V over I. So I is equal to V over R. So we can actually calculate the current here by the 4 ohm resistor, where I is equal to V over R, and that's equal to 2,8 over 4. And on the calculator, I don't have a calculator with me at the moment, but that will be 2,8 over 4 amps. Okay. Now, what we know of resistors in parallel is that if that in parallel the voltage remain the same. So if 2,8 volts is in this branch, here's 2,8 volts in this branch as well to the 1 ohm. You understand? So if we got 2,8 volts there and we got 1 ohm here, we can calculate the current here, and the current is equal to V over R, which is equal to 2,8 over 1, which is equal to 2,8 amps. So 2,8 amps flows through this branch, and 2,8 divided by 4 amps flow through that branch. Can I just find out the calculation of 2,8? So 2,8 2.8 divided by 4. So that is 0.7. So that is 0.7 amps. So if 0.7 amps past the 4 ohm and 2,8 amps past the 1 ohm, remember, current is coming all the way from this side of the circuit. It flows and it flows and it flows. At this point, the current splits into two. So it splits into the 0.7 amps and it splits into the 2,8 amps. So remember, the current in a parallel circuit, they add up. So we have to actually add up these currents to find out what is the current that leaves this parallel party. So this over here is a parallel party because these two resistors are in parallel. You understand? So 0.7 plus 2,8 is 3,5. So 3,5 amps leaves the parallel party. You understand? And it returns back to the battery. In this circuit over here, this is a parallel party. Alright? These two resistors are connected in parallel. I call it a parallel party. There's no other resistors that is connected to this parallel party. You understand? So we can actually tell ourselves that this 3,5 amps is actually our external current, because that's the current in my external circuit that came from the battery. Remember, we have an internal circuit. In terms of circuits, we have an internal circuit and we have an external circuit. So I actually understand that this 3,5 amps is actually external current, and we can plug that into this graph. So 3,5 is external current, and external current is equal to the total current. So that's what we did first. We first calculate the external current, then we said that's the total current. Now if we got total current and we got total voltage, we can actually calculate R total, because R is equal to V over I. So here we can say R total is equal to V over I. So just make a note for yourself here that R is equal to V over I. So which is equal to 3 over 3,5. 3 over 3,5. And 3 divided by 3.5 is equal to 0,857. 0,857 ohms. Okay. I'm gonna stop there for now. Or let's not stop. Let's go on. So we have number 3. We got now total resistance 0,857. 3 divided by 3,5. Now, can we get external resistance? Okay. Because if we can get external resistance, we can calculate our internal. because then that would be the only variable in this column. So what is R external? So R external is all the resistors in my external circuit. It's the total resistance of my external circuit. And the only resistors here is the resistors in my parallel party. So for my parallel party, what we can actually do, we can actually calculate RP. So 1 over RP is equal to 1 over R1 plus 1 over R2. So 1 over RP is equal to 1 over 4 plus 1 over 1. Because that's 4 ohm in that branch, in branch 1. And in branch 2 there's 1 ohm. So 1 over 4 plus 1 over 1. So 1 over RP is equal to 4, 1 plus 4. So 1 over RP is equal to 5 over 4. Now you flip it. Flip both sides around. So therefore RP over 1 is equal to 4 over 5. So basically RP is equal to 4 over 5, which is equal to 0.8 ohms. Okay, so the parallel party, the effective resistance in my parallel party is 0.8 ohms. And that's the only resistors in my entire circuit, is the resistors here in parallel party. So my external resistance of my circuit is 0.8 ohms. And we know how to calculate that. We just did it here. Okay? Then we can the reason why I'm numbering it so that when we study, we know what we did first, what we did second, what we did third. And we can remember what to put for the examiner also. I didn't go to the question yet, you see, because I'm busy analyzing it first to make you understand what's happening. Okay? We can calculate internal resistance because if R total is equal to R external plus R internal, R total is equal to 0.857, which is equal to 0.8 plus R. Take 0.8 over 0.857 minus 0.8 is equal to R. Therefore 0.057 is equal to R. So 0.057 ohms is your internal resistance. Now external current is equal to internal current. Therefore 3.5 amps is internal current. If you have internal current and you have internal resistance, you can actually calculate internal voltage, which is current times I times R. So 3.5 times 0.057, 3.5 times 0.057, 0.1995, which is 0.2. It's about 0.2. 0.2 volts. And then lastly, we can calculate V external by saying V total minus V internal is V external. So that's 3 minus 0.2, which is 2.8 volts. Now, do you see, once you got this, we actually got everything that they can possibly ask us. So they can ask us anything, we're gonna know, we're gonna have everything what they want to ask us. So let me recap. So first, they say that they gave us the voltage across the 4 ohm. If you got two variables, you can immediately calculate the third variable. So we got the voltage and the resistance. We then calculated the current using the formula. Then we use our principle that the voltage in the parallel circuits remain the same. So if 2.8 volts across the 4 ohm, these 2.8 volts across the 1 ohm. Then if you have voltage and resistance, you can calculate your current using your formula. I is equal to V over R. We got 2.8 amps. Then we said that the voltage, that the current in the parallel circuits adds up. Then we added the current across each branch to give us the current leaving the parallel party, which is the external current. So that 3.5 amps enters the party and the same number of amps leaves the party after it splits, and then they add up again. Okay? Then, so that we got external current. Then we say external current is equal to total current. Then within this row, we can get R total by saying V over I. We got R total. Then how do we get our external? We see that we got external resistances by the parallel party. So we can use the resistance in parallel formula, the total resistance in parallel, to calculate the sum of the resistors in parallel. Then we got 0.8 ohms. Then we said, okay, our internal is equal to our total minus our external. Then we got 0.057 for our internal. Then we said, hey, internal current is equal to external current, which is all of these currents are the same, so it's 3.5 amps. If you have current and resistance, you can calculate voltage by saying I times R. So you say 3.5 times 0.057, then we got 0.2 voltage, which is internal voltage. And then we got total voltage, and then we had the internal voltage, which we can calculate external voltage, which is 3 minus 0.2, which is 2.8 volts. And believe it or not, that 2.8 volts is the same 2.8 volts that we discussed earlier on. And that is amazing. Okay, so I hope you found it amazing. Right though. Now we go to the question. The question 1 says, calculate the question 9.3. Question 9.3 says, calculate the total current in the circuit, I total. So let me show you what you must write to the examiner. So what you write for the examiner, or what's the examiner going to mark? The examiner, I can maybe use a different color. The examiner, what you must write for the examiner, write this for the examiner. You're going to get a mark for that. So the examiner is looking for total current, right? Then you're going to get a mark for that. And then you're going to get a mark for adding, for getting I external. We're getting I external, because we got I external by adding the current. So if you can show the examiner that you're adding the currents by saying I external is equal to 0.7 plus 2.8 is equal to 3.5, you're actually going to get a mark for that. Then afterwards you say I external is equal to I total. Therefore I total is equal to 3.5 amps. You get a mark for that. It's 5 marks actually. You're going to get 5 marks. But anyway, so that's all the examiner is going to mark for that question 9.3. Okay. In the next question they say calculate the internal resistance of each cell. Now be careful. They're saying calculate the internal resistance. So 9.4. Okay. 9.4 is the internal resistance of each cell. So the internal resistance of each cell, what's the examiner going to mark? So this table is going to help us, because now we're going to know how the flow works. So we know our answer. This is our answer, right? But we're going to work all the way down to our answer. So we're first going to show the examiner that we can get R total. So the examiner is going to mark you on getting R total, which is equal to V total over I total, V over I. Right though. Then the examiner is going to want to know how to get R external. And you get R external by using the RP formula. So you're basically going to get a mark for that and a mark for that. So you write that for the examiner at 9.4. Then for our internal, you do this for the examiner, and you're actually going to get a mark for that as well. And there you got all your marks. But remember, this internal resistance is total internal resistance. Then if you want to get for each cell, you must say 0.057 divided by 2. That answer in ohms is the resistance for each cell. And that's it, everybody, for this question. In the next video, I'm going to do 9.5 for this exam. Past paper.